We will continue with the concept of finding probability, but today we will introduce the two types of probability, theoretical and experimental probability. Let's directly take an example. A coin is tossed one time. Find the probability of tossing the coin and landing on the head. As you know, whenever we toss a coin, it will either land on its head or the tail. Those are the two possibilities for tossing a coin. Let's now find the probability as we learned earlier. The probability for landing on the head, so they want the heads, it is equal to, we know that it's a fraction. We need to write the denominator as the total possibilities or total number of outcomes. The total number of outcomes is 2 because we only have two possibilities, either heads or tails. Now, the numerator is how many heads do we have? We're finding the probability of heads. As you notice here, we have only one. So the probability of the heads is 1 over 2. Or if they need it as a decimal, it's 0.5. And as a percentage, it's 50%. Now, when we started, I underlined one time. Why did I underline one time? Because this is called a theoretical probability. When we divide the number of favorable outcomes by the total number of outcomes, we are getting the theoretical probability. So the previous two sessions, we were always calculating a probability that is known as a theoretical probability. So theoretical probability is the number of favorable outcomes divided by the total number of outcomes, which is the regular probability that we were calculating. Question number 2. A coin is tossed 50 times and it lands on its head 28 times. Find the experimental probability. So here we're introducing a new type of probability. It is known as the experimental probability. Why is it an experimental probability? Because as you notice here, we're not tossing the coin one time. We tossed it 50 times. This means we did an experiment. We did the trials. We kept on throwing it 50 times. And out of those 50 times, it landed on its head 28 times. How do we find an experimental probability? To find an experimental probability, you have to divide the number of times the event occurred. This means the number of times it landed on its head over the number of times the experiment was done. And here we did this experiment 50 times. Then the experimental probability of heads is equal to the number of times the event occurred. It's 28 times it landed on its head, so it's 28 divided by the number of times this experiment was done. We tossed the coin 50 times, so it's divided by 50. Again, if there is a possibility of simplifying, we need to simplify this fraction divided by 2 to get 14 out of 25. If we need it as a fraction, we divide the numerator by the denominator to get 0.56. And if we need it as a percentage, we multiply it by 100 to get 56%. So as you notice here, we were asked to find the theoretical probability in the first part, second part, the experimental probability, and there will be a third part. The third part is comparing between the theoretical probability and experimental probability. When we want to compare them, as you know that the theoretical probability is 0.5 and the experimental probability based on our calculations is 0.56. As you can see here that they are close to each other. So the theoretical and the experimental probabilities are close to each other. What does this mean? When both probabilities they are close to each other, this means that the experiment that we did, which is throwing the coin 50 times, was enough. We did enough trials. So what does this mean? There are enough trials. Now, in case they are not close to each other, what would that mean? This would mean that we need to do more trials. So to wrap up this lesson, before we take extra exercises, I need you to look at the summary here. You will be asked to find the theoretical probability. Again, theoretical probability is the same probability that we have been calculating for the past two sessions. It is the number of favorable outcomes. How many do I have? Even numbers, vowels, etc., over the total number of outcomes, the total number of values that we have. Experimental probability is, here we have an experiment, so we are going to repeat the experiment many times. To get the probability, it's the number of the times the event occurred over the number of times the experiment was done. Then you will be asked to compare them. Why am I supposed to compare them? To see whether the theoretical probability and the experiment probability, are they close to each other? If they are close to each other, this means you did enough trials in your experiment. You don't need to do more. Your experiment was fair to get the probability. In case they are not close to each other, this means your experiment was not fair and you need to do more trials. You did not have enough trials in your experiment. We have a new question here. We have a spinner of 4 different colors and it was spun one time. They want us to find the theoretical probability of the spinner landing on blue. Theoretical probability, we're going to use the first formula, and it is the usual probability calculation that we did before, and it is going to be the probability of landing on blue. It's going to be a fraction, and this fraction, the denominator is the total number of outcomes. If you look back at the spinner, you're going to find we have 4 outcomes, and they are blue, red, yellow, and green. So the denominator is 4, and the numerator is the number of blue. Here we have only 1 out of the 4 parts they are or is blue. And if you want to write it as a decimal, 0.25 as a and it is 25%. In the second part of the question, we have spun the spinner 23 times and it landed out of the 23 times 2 times on blue. They want us to find the experimental probability. Remember, experimental probability, this means we have done an experiment, we did many trials. Here we did 23 trials. In the experimental probability, we're going to refer to the second formula, and that's the number of times that the event occurred. The event here is landing on blue, so it landed on blue 2 times. Then the probability of blue, the experimental probability, is 2 divided by the number of times the experiment was done or repeated. Here we did the experiment 23 times. We cannot divide or simplify more than that. We're gonna go for decimal. It's 0.087, and as a fraction it is 8.7%. There is an important note that I would like you to understand. When we find the theoretical probability and the experimental probability, it's for the same event. Here, landing on blue, landing on blue. I cannot find the theoretical probability of landing on red and experimental probability of landing on blue and compare them. No, they have to be the same event to be able to compare them. Last step, we need to compare the experimental and the theoretical probabilities. If you notice here, the theoretical is 0.25 and the experimental is 0.087. So definitely they are far away from each other. They are not close to each other. What does this mean? If they are not close to each other, remember, what did we say? This means that the trials that we did are not enough. So we simply write that not enough trials were done. The trials are not enough. For example, find the theoretical probability of choosing a heart from the cards above. We have 4 cards: triangle, heart, circle, and a square. They want us to find the theoretical probability of choosing a heart. Again, theoretical probability is equal to the number of the favorable event or outcome, and the outcome here that is favored is choosing a heart, and we only have one heart, divided by the total number of outcomes. As you can see here, we have 4 outcomes only, as we listed earlier, so it's 1 out of 4. If we need it as a fraction, it's 1 out of 4. As a decimal, it is 0.25. And if we need it as a percent, it's 25%. Question number 2. A heart was randomly chosen 7 out of 12 times. So here we are doing an experiment. We are choosing 12 times. And out of those 12 times, 7 times we have chosen a heart. Find the experimental probability. The experimental probability of choosing a heart is equal to the number of times that we got a heart, which is 7 times, divided by the number of times the experiment was done. This experiment was done 12 times. We cannot simplify it more, and now we can write it as a decimal. 7 divided by 12 is going to give us a 0.583, and if we want to write it as a percent, it is going to be 58.3. Last part, compare the theoretical and the experimental probabilities, and then we need to explain. Now, I listed above the probabilities that we calculated earlier. As you notice here that 0.25 is the theoretical probability, and the experimental is 0.583. As you notice here, they are very far away from each other. So definitely they are not close. And if we need to explain, as we listed before, that the trials that were done were not enough.